Hey guys, this is Professor Janacek, and I just want to talk about some of the properties for derivatives. Now, I'm not going to prove any of these here, but there are some nice, elegant proofs using the definition of the derivative. So the first property is that if you take the derivative of a constant, you simply get 0. That's pretty easy to remember. Now, if you take the derivative of a constant times some other function, then you simply take the derivative of the function, multiply that by the constant. So it's sort of like factoring out that constant. Now, the next one, if we take the derivative of the sum or a difference of two functions, we could actually take the derivative of each function independently and then add or subtract them. This is often referred to as either the sum or difference rule. The next rule is kind of nice. It's if we're taking the product of two functions, f times g. If you take the product, if you're taking the derivative of the product of two functions, there's actually a procedure for finding that derivative. It's the derivative of the first function, f, times the second function, as is, plus the first function, as is, that's f, times the derivative of the second function, in this case that's g. So notice I've got the derivative of the first times the second plus the first times the derivative of the second. There are other ways of writing this. There are lots of ways of writing this. This is referred to as the product rule. But because addition and multiplication are both commutative, I could have written this as, I don't know, I could have written it as gf prime plus g prime f, or we could write it as f prime, hold on, f g prime plus f prime g. There are probably half a dozen other ways of writing it, all of which are correct. However, I like to remember it in this fashion. Again, that is the derivative of the first function times the second function plus the second function times the derivative of the first. I like to follow that version of it because if you look at this next rule, this is when I'm taking the derivative of a quotient of functions, you'll notice the numerator of this follows the same pattern. The derivative of the first times the second minus now the first times the derivative of the second, and then of course we divide all this by the second function, or the bottom function, squared. So again, you could say top and bottom, first or second. The first function is my numerator, the second function is my original denominator. This is referred to as the quotient rule because we are taking the quotient of two functions. Again, there are all kinds of ways of remembering this, but I find it helpful if we kind of connect the pattern from the product rule with the numerator of the quotient rule. The next rule is if we're taking the derivative of x raised to the nth power, what we do is we take that exponent, and multiply it in the front, make it a quotient, and then the exponent we reduce by 1. This is referred to as the power rule. And then finally we have this last rule that I want to mention. It's if I'm looking at a composition of functions. Notice f is my outside function, if you will, and g is the inside that composition. If we're going to take the derivative of that, then what you do first is you take the derivative of that outside function on the composition, leave the inside function as is, and then multiply by the derivative of the inside function. This is referred to as the chain rule, and this one comes up all the time. So often people forget to use the chain rule, but you always want to be looking for this chain. Is there some inside function that we can work with? And we will look at examples. I'll have another video where you can look at some examples of all of these different rules. Here at the bottom, I also want to mention some common derivatives. trigonometric functions, inverse trigonometric functions, and also, oh, some really nice ones, the exponential and logarithmic functions here at the bottom of the page. So take a look at those. We will look at some examples of all of this stuff in upcoming videos. So enjoy.